everybody, welcome to video notes 5.3, predicting products. Woohoo, finally, let's say what's going to be made when chemicals react. Please continue to read chapters 6 and 7 of the book. And we already know how to identify chemical reactions by looking at the reactants. So here's what we're looking for to decide what kind or type of reaction will take place. So here's what you have to look at first. Once you know what kind of reaction it is, it's easy to predict because in a synthesis reaction, since you're only making one product, another name for combination, then you have to cancel the charges of the elements involved to make the compound. In a decomposition reaction, since you're only starting with one reactant, you got to break up the reactant into products, and we're going to go to elements. And then in combustion, once you recognize it's combustion, you know the products are going to be H2O and CO2. Oh, here's some samples. Calcium reacts with oxygen. So we have calcium, which is a solid metal, reacting with oxygen. Diatomic. All right, so this is combination reaction synthesis. So the only thing that could form is the combination of calcium and oxygen. And Ca on the periodic table is +2, O is a -2. So we're going to get CaO. It's an ionic compound, and so it's going to be solid. And then we have to go back and balance the equation by putting in coefficients. So we're going to need a 2 there, a 2 there, boom, done. Okay. Nitrogen dioxide decomposes. First, let's write the chemical formula for nitrogen dioxide. 1N, 2 O's. I'll let you know that's going to be a gas. Decomposes, we know there's only one reactant. So now we have to break this compound up into its elements. So we're predicting the products to be nitrogen and oxygen. But wait, are either of those diatomic? Well, you know the word, Nafkulbrich. And guess what? Both of those are in there, so we need T's next to them. They're both gases. And so we correctly write the formulas of the products. Then we go back and say, oh, there's only one N on this side and 2 here, so we need to put a 2 there to get 2 N's, 2 N's. And I'll need a 2 there. Okay, H2S, one reactant. What does one reactant do? It decomposes into hydrogen and sulfur. And then we remember that hydrogen is in Nafkulbrich. So they put in a 2 there, and we put a gas. Sulfur is a yellow solid, and then we count 2 H's, 2 H's, 1 S, 1 S, it's already down. So we're good. Okay. Zinc reacting with oxygen. All right, 2 elements, so we know it's going to make a compound. So we look up on the periodic table, Zn is always +2, oxygen is a -2, so the chemical formula is ZNO. Do not try to put ZNO2, because it can't be ZNO2, because it's a +2 and a -2. Okay, I'll let you know it's a solid. And then we check to see its balance. We need 2 there for the 2 oxygen. C2H4 burns. That looks like combustion, because this is a hydrocarbon. So we need C2H4, and we need to make it burn, so we need oxygen. And we're always going to get carbon dioxide. And those are going to be gases. And so this is a gas. So then we would need to balance the equation. So we need 2 carbons over here, 2 carbons over there, 4 hydrogens, and then we have 2 plus 4 is 6 oxygens, so we put a 3 there. Okay, we just predicted products for 5 different reactions. Way to go. All right. Oh, no, there's more. All right, 2 elements, so we know they're going to cancel the charge. Sodium's a +1, sulfur's a -2, so it's got to be Na2S. We'll balance these later. In fact, I think we're going to save the rest of these for in class, right? So see if you can do it. We'll check them in class. Hey, there's another type of reaction called single replacement. Now, single replacement is where a compound in an element, the element tries to kick part of the compound out, okay? So we have to check the activity series to see if that's going to happen. And then we got to look for diatomics and for canceling charge for compounds. Okay, so here we go. Single replacement. How do I know? Element, compound. So I have to see if the element, the one that's by itself, which is a metal, so I can check the metal series, and have to see if it replaces the other metal. So here's potassium, here's sodium. Yes, potassium can kick out sodium, because higher ups can kick out lower downs. Okay, so potassium's more active than sodium, so then we have to put potassium, which is the +1, together with chloride, which is the -1, so we get KCl. What got kicked out? Potassium or sodium got kicked out. And then we just double check that we're balanced. Okay, so we have tin trying to kick out something in this compound. So tin is on this list, and aluminum's on this list, but look, tin is lower than aluminum, so this is a no reaction because tin is not active enough to kick out aluminum. Okay, so now we got lithium iodide and bromine. The element, the thing that's by itself, is a non-metal, so we have to check the non-metal activity series. And we look to see if bromine is higher than iodine, and it is. Right? So bromine will kick out iodine. So now I have a lithium with a +1, a bromine with a -1. I get LiBr. Right? What got kicked out? Iodine. But wait, watch out for diatomics. Iodine is a 2 because it's one of the diatomics. And then this is going to be aqueous, and iodine's actually a solid. Okay. So iodine got kicked out. And now I have to make sure coefficients to balance it. Okay, now the element by itself is a non-metal. So I have to check the non-metal activity series, see if chlorine's higher than fluorine. It's not, so this is a no reaction. No reaction. So alright, that was single replacement. What's next? Double replacement. Okay, in a double replacement, the products are two compounds. And one will most likely be a solid, and we're going to use Coulomb's law to predict by multiplying the charges. If we get 4 or greater, it's going to be precipitate. If we get less than 4, it's going to be aqueous. There are some heavy metal halide exceptions and hydroxides to this, but iodide solid, silver chloride solid, etc. Okay, so here's actually some solubility rules, but they pretty much follow Coulomb's law because nitrates are -1 charged acetates, chlorates are all -1, so any any ionic compound with those 3 ions in it is always going to be soluble. Look at all of these are +1 charges, so any compound with those in them will be soluble. These are all -1s, so it should be soluble, except for our heavy metals, silver, mercury, lead. So we're going to practice these in class using our solubility rules, our Coulomb's law. So one thing you can look for, though, is if you look at this one, calcium sulfate. Sulfates should be soluble, it says, but this is a +2 and that's a -2, so that equals 4. So this is going to be solid precipitate. Okay, so what is a PPT? A PPT is a precipitate. It means it's insoluble, makes it solid. We could put a down arrow on the X, right? So this is an example of a solid precipitate. What is not a precipitate? It means there's some aqueous dissolved in water, and that's soluble. Okay. S is for solid, not dissolved in water, insoluble. And we use Coulomb's law for solubility rules. Oh yeah, say good. Okay, so what does AQ really mean? For ionic compounds, AQ means water pulls apart compound and surrounds each atom. Okay, so if these are negative ions, look, water surrounding them. If these are positive ions, water surrounding them. Okay. So the anion gets surrounded by positively charged side of water. The cation gets surrounded by the negatively charged side of water. So NaCl solid turns into NaCl aqueous when it dissolves in water. But what that really means is Na positive ions are surrounded by water, and Cl minus ions are surrounded by water. So anytime you see an AQ, this is what it really means. Okay? All right, covalent can also be aqueous. So this is ionic again, and you can see the water surrounding the positive and negative ion. What does covalent mean? Covalent means you have a polar substance. So this is one molecule, another molecule, another molecule. And so what water does is it surrounds each molecule. Okay? Water surrounds each polar molecule. So the molecules don't break apart into charged states. They just get surrounded. So if you have C6H12O6 solid, it really turns into C6H12O6 aqueous, where every piece of, so this is C6H12O6, each one of those. Okay. And so each one gets surrounded by water. So covalent compounds don't break apart into ions, but they do dissolve, but they don't dissociate. All right. It's not actually a chemical reaction, but it's how solutions are formed. Ionic compounds dissolve and dissociate, so get surrounded by water and break apart, break into ions. And then covalent compounds just dissolve and hold water molecules and get surrounded by water molecules. So we have to say, okay, this is ionic. So that means it's going to break apart into calcium ions that are surrounded by water and fluoride ions that are surrounded by water. But wait, you say, what about this too? Every time this breaks apart, you get 2 chlorides for each calcium. Okay, this is covalent, right? So it's just going to get surrounded by water. Ionic, so this is going to get surrounded by water. So we have sodium ions that are surrounded by water and phosphate ions that are surrounded by water. You might be saying, but wait, Mrs. Harbin, what about this 3? That means every time this breaks apart, you get 3 sodium ions for every 1 phosphate ion. Okay, that's dissolving. That's what AQ means. All right, so in double replacement, every reaction is going to occur because one of these 3 things is happening. Either a precipitate is forming, a gas is forming, or water is forming. So here's some samples for double replacement. How do I know it's double? Because it's a compound and a compound. So we have NaCl, because it's a +1 and a -1. And it has to be aqueous to start with. Reacts with lead, so Pb +4, hydrogen +4, nitrate, NO3 negative. So we need Pb and O3, 4, aqueous, okay, to form. So now we got to switch a root, but we know the sodium is going to be in front and the lead's going to be in front. So we have to get the nitrate with the sodium. Nitrate's -1, so I write NaNO3. And lead, or chloride's -1, so I need Cl4. Alright, so first I have to get the correct chemical formulas based on calcium chart. Then I have to see which one's soluble and which one's insoluble. I know this is a +1 and a -1, so this is going to be aqueous, because Coulomb's law gives a small charge. +4 and -1 is going to be solid. Okay. Copper 2 sulfate reacts with barium fluoride. Alright, so we have a Cu +2, sulfate SO4 -2. So we have CuSO4. Okay. Every reactant in double replacement is aqueous. Barium fluoride is a +2 and -1, so it would be a 2, and that's aqueous as well. Alright, switcheroo. So we have copper because it's first and barium because it's first, +2 with a -2, so 3, right? +2 with a -1. Alright, so which one's aqueous and which one's solid? So +2 -2 equals 4, so this is going to be the solid, and this is going to be the aqueous. Alright, there's one other thing we have to do, is put in coefficients. So I'm going to need 4 there, 4 of those, 4 there. Over here, we've got 2 fluorines, 2 bariums, 1 sulfate, 1 copper, it's already bounced. Finally, potassium phosphate is a K, PO4, PO3, aluminum AL, nitrate, NO3. So, I have a K3PO4. That's aqueous because reactants are aqueous. Aluminum, and then NO3. And that's aqueous. So, it has to form, a K has to go with a nitrate. Oh, come back. So, K first, NO3, because +1 and -1. And then aluminum phosphate is a +3 -3. That's how that works out. And this is a +3 -3, so it's 6. So this is a bare solid. +1 -1 is our AP. And it looks like omega 3 there. Alright, so we did all the reactions. So, how do you know what state of matter to put in? All metals are solid except mercury. Okay, so Hg is going to be a liquid, but all metals are solid. Diatomics are gases except that bromine's a liquid and iodine's a solid. Probably want to write this down and remember it right there. Okay? And then we'll keep practicing. Ionic compounds are solid and decomp and combo. They're aqueous as reactants in double and single replacements. But we got to check the solubility rules and Coulomb's law. Check the solubility using Coulomb's law for products of double replacement and combustion gives gases. Write this down. Use it. All right, finally, what are these? Predict products, include states, balance, and coefficients last. So we're going to do this in class, but I want you to try it, and then we can check it. Right? You might want to realize to review that you got to recognize the type of reaction. Cancel charges for ionic compound. Use your PT. use PT and memorize ions. Memorize ions for sure. Okay. Activity series for single replacement. Check it. Alright, Coulomb's laws for double replacement. 4 or greater is solid. Combustion is always the same, H2O, CO2. Know your diatomics. And you know what AQ means, is dissolved in water, and what is dissolved in. So, please read the book, know all these objectives, and have a great rest of your day. Peace out from Harbin.